Hey everyone, my name is Max Edson, and this is my final project for CS4510. So for this project, I chose a theorem that stated that 3-tape Turing machines can be simulated efficiently using only 2 tapes. The main idea I'll be using to prove this theory is by that proving we can leave one tape as it is and merging the other 2 tapes into one. The reason I'm doing this method is that I cannot find many resources online regarding this theorem specifically, so I'll be using some other ideas and theorems to prove it. One of those concepts is the Church-Turing hypothesis, which essentially states that anything that can be computable is computable by a Turing machine. So kind of this idea that computing a multi-tape Turing machine can also be computable by a single-tape Turing machine. And then also this idea of Turing equivalence, which was proven to be true, that multi-tape Turing machines are equivalent in power to ordinary Turing machines. So this concept of going from a multi-tape Turing machine to a single-tape Turing machine and vice versa, I'll be using that as the basis and the fundamental of my proof regarding 2-tape Turing machines and 3-tape Turing machines. So displayed here is a figure showing an equivalent multi-tape Turing machine and a single-tape Turing machine. As you see, the single-tape Turing machine is holding all the same data. You can see the 01010 from tape 1, the AAAs from tape 2, and the BA from tape 3. And the reason a single tape is able to hold all this information and separate the 3 strings is by separating them versus the pound symbol. That way the Turing machine always knows which is string 1, which is string 2, which is string 3. And even though it only has one head, it's able to mark all 3 heads as needs by just putting a little dot over where the head is for each string. So this is what we're going to be doing with 2 of the tapes. We'll leave one tape as it is, and the other 2 tapes will be merged in together in this sort of fashion. That way we can simulate the 3-tape Turing machine with 2 tapes. The first thing we need to do is to modify the alphabet. We need to add a separation symbol, which can be anything as long as it is not already in the alphabet. For this video, I'll be using the pound symbol. This is so the Turing machine knows when one string ends and another begins. And secondly, we will need a way to mark all the heads. Since a single tape can only point to one cell at a time, we will be creating a modified version of each letter in the alphabet to mark it as the head of the string. In this video, we will be using a dot on top of the symbol. And below is just an equation that states that we are going to double the size of the alphabet and adding 1 for the separation symbol. So here's an example of converting a 3-tape Turing machine into a 2-tape Turing machine. As you can see, on top we have 3 tapes separated by color, and below we only have 2 tapes. So we're leaving tape 1 the same, while for tape 2 in the 2-tape Turing machine, you can see that we are merging both strings with the pound operator. So tape 2 begins with a pound, has the AAAs from tape 2, pound again, and then has a string from tape 3. So now we're going to simulate what this new Turing machine looks like. So the first part of any state is that we need to check the heads. That way we know what values to do and what state and what contents to modify after that. So for this Turing machine, the first head points to 1. We can see that first is our first tape. And then we move on. We would need to move to where string 2 has that dotted character. That way we know that's where the head is. So we start at the hashtag, move to the first A, the second A, and then finally at the third A, we see the dot over it. So it's like, okay, that's the head of tape 2. So we're going to put the A in that spot. And then we got to go find head 3. So we move. You see the pound symbol. I was like, okay, I'll be on the lookout. We need to look for this dotted symbol. That way we know where the head is. And it happens to come right away with the B. And then just after checking the heads, we'll just go all the way back to the beginning. That way we know the first thing that we encounter will be string 2. So now that we are done checking the heads, we can finally go about applying changes. And we're just going to follow along with an example. So we're going to do the corresponding action items to each of the tapes. So for tape 1, we're going to replace the head with 0 and move to the right. This is pretty simple as it just acts as an ordinary single tape Turing machine. We will replace this one with a 0 and we will move our head over to the right. For tapes 2 and 3, this is interesting since it's not on a single tape line. So we'll do the same thing we did with checking the heads. We'll move our pointer over to reach the head, and then we will just follow the action items as they do. So in this scenario, we're going to replace it with a B and move to the left. Since we are moving to the left, we know that this cell will not be the head, so we won't replace it with a B dot, and we'll just replace it with a B. And we move over to the left, we need a way to designate this new cell as the new head, so we'll replace the A with the dot. That way when we come back around, we know that this spot is the spot with the head. And then we're going to move over till we find tape 3's head, and here we are. This A, we're going to keep the B and stay. So we're going to keep the B here, and the head's also just going to remain here. And then we'll move our pointer over to the beginning, so we know string 2 is going to come first, and then we'll just progress along to the same state. So that's just going to be the fundamental idea of how we go about checking states and how we go applying the changes. The state transitions and the accepting and rejecting states will remain the same throughout, and that's just how we're going to simulate it using 2 tapes. There's one concern that we do need to address, and is this: how do we go about adding space? Like if we want to add new cells to another string, how do we do that if there's separation operators and string in between? So for our first string in this tape, you can see that our head is at the last possible character. So what if we wanted to add a B to the right of the head? We don't have the unlimited amount of space directly to the right of this head. So we're going to have to figure out a way to add a blank space to the right of it while maintaining the contents of string 3 and all the separation operators. So to do that, we will need to shift every single operator over 1. So what that means is that we're going to have to scroll all the way over to the end and find this new blank space. And then one by one, we'll have to shift every element over. So this one's become the pound sign, go back, that one's going to become A, we go back, that's going to go B with that pointer so we can keep the head. The next one over is going to be the pound symbol. And then finally, we have this extra free blank space where we can add the B. And then since we're adding in a B, in addition, we got to add it with a B dot. That way we can designate it as a head. And then we go back to our original A and rewrite it as the original A. So that's how we're going to do it. And we can just scroll on over and just simulate the rest of the state. And yeah, just wanted to thank to whoever ends up listening to this for listening to it. Just thank the professor and the TAs for just a great semester. This automata and computational theory, a lot of it feels like it goes over my head, but y'all did a really good job helping me out and explaining the material. It's really fascinating stuff, and yeah, just thank you for just a great semester.